Once again, a very warm welcome to all of our attendees this morning. We want to say thank you very much to all of our plumbers out in the industry, as well as those who are joining out from other industries or other businesses for these Toolbox Talks. We also want to say how much we appreciate your valuable input. The feedback that we have been receiving from you via email has really been fantastic, as well as all the extras and the information that you want to hear throughout the Toolbox Talks coming up. We are putting this into place, and we hope that you get to hear your Toolbox Talk soon. As always, we want to start off with the tips to continually prevent COVID-19. But as always, we also want to look at the prevention of COVID-19 or other airborne, waterborne, or natural-borne diseases. This is just basic hygiene that we want to keep on all of our sites. Washing your hands regularly, using sanitizer if you don't have water and soap available. Avoid touching your eyes, nose, and mouth with unwashed hands. And then if people are sick, adhere to your social distancing measures continually. If you have a cough or a sneeze, please use a flexed elbow or a tissue and throw that tissue into the bin. And then something that plumbers, you should be doing automatically, even though COVID is here and it has shown us more and more that we need to disinfect and clean frequently touched objects and surfaces. This should really become something natural in terms of our housekeeping procedures as well. Cleaning and disinfecting all of our tools, hand tools, and equipment that are frequently touched because of the working environment that you are in. A lot of plumbers are exposed to hazardous biological agents or hazardous biological substances, or even the cross-contamination between the plumbing where you are working on site and the tools that you might be taking back in your vehicles. So please try and keep this as some utmost importance for your current procedures. And if you can, if you haven't been vaccinated yet and you can do that, please do that. If you don't want to get vaccinated, it's obviously your personal decision, but please ensure that your company has a policy on vaccination and adhere to that vaccination policy as much as possible. Now, with the Toolbox Talks coming up for today and next week, we are looking still at plumbing risk. So today we are looking at the electrical risk for plumbers, and next week we are looking at the water risk for plumbers. Obviously, as a plumber, you are exposed to water all the time. But on the electrical side, you are exposed to it to a degree or in various degrees. So let us take a look at the different hazards and risks that you will face as a plumber. Our safety thought again for this week is do not let overloaded sockets turn you off. Obviously, electricity is dangerous, so please remember, we never want to take anything for granted when it comes to electricity. Now, to start off, what is electricity? Well, electricity is the flow of electrical power or charge. It is a secondary energy source, which means that we get it from the conversion of other sources of energy like coal, natural gas, oil, nuclear power, or from natural sources, which are called primary sources. Now, while the amount of current over 10 milliamps or 0.01 amp is capable of producing painful to severe shock, please remember that currents between 100 and 200 milliamps, this is 0.1 or 0.2 amp, are lethal. In fact, you could actually die from a shock from this type of milliamps. Now, for most electricians, you will automatically know that any type of electricity is actually dangerous, regardless of whether it's 0.01 amp or even 0.1 or 0.2 amps. And that is because the effect on the human body can be very dependent on the person. Now, what we want to just encourage you to do is make sure as a plumber, or even if you're a plumber, electrician, that you constantly guard against this type of danger. Now, there are 4 areas that we want to discuss with you this morning because you are installing geysers, hydroboils, pumps. Perhaps as an electrician, you need to come and then do the COCs on geysers, hydroboils, or pumps, or any other plumbing machinery, plumbing equipment, or even just the installation around the plumbing that might include the need for electricity. Even some toilets nowadays, such as your toilets from Propel Air, also have to have an area of electrical input for the actual toilet to be working. So there might be a small area of electrical work. There might be a very large area of electrical work. The difference is, no matter what you are doing, whether you're a plumber only and not doing the actual physical electricity, you will still be exposed to certain parts of the electrical hazards. As you can see in the picture on the left-hand side, even just digging a trench or perhaps the excavation that you're using to do waste piping, you could come across other services in the ground. And so it's very important that you actually notify your client beforehand of the additional services that might be there so that a survey can be done or testing and inspection for underground services can happen. This is obviously in accordance with legislation. Before any digging has to happen for excavations or trenching, underground services must be checked for so that you can prevent the exposure to digging into an electric cable and then causing an electric shock. But the 4 areas that we want to mainly focus on is before the installation of any plumbing, during the installation of plumbing, during the testing of this plumbing, as well as when performing inspections. And that is an area where many plumbers are actually failing. So let's take a look at the first 3, and then we're going to focus mainly on the performing of inspections. And the reason for that is not because there's a higher risk, but because there is a higher lack of regard to safety when just performing inspections. Now, all plumbers should know and understand the danger of energy sources and the potential for serious injuries or even death. Again, even though you are not an electrician and your plumbing employees might only be performing manual labor in terms of plumbing and no electrical work, you should still know and understand the dangers because you will come across it during your specific tasks. So the first part is before the installation. Now, again, whether you're doing your own electrical work or whether you're going to outsource this to a subcontractor, it's vital to ensure that all energy sources are isolated or locked out before you can start working on any plumbing that needs to be energized. The first thing you want to do is identify potential live energy sources. For instance, if you're going to be climbing into a ceiling to install a geyser, to check on a geyser, perhaps you need to replace a thermostat. Before you climb into that ceiling, you need to identify not just the live potential energy sources for the work you're performing, but what about the environment around you? You see, there could be electrical cables that are energizing other parts of the home or other parts of the business that you will need to go through in order to get to the installation. Now, we're not saying that you're going to shut off the entire house. You might just have to isolate a certain breaker on the DB board for the actual source of energy to the plumbing that you are going to be checking on or before you're going to be installing it. But you might be exposed to live wiring, loose wiring, or exposed wires when moving in and out of the actual ceiling. So identifying it means you need to perform an inspection. Now, the best way to perform an inspection is to document the inspection using a step-by-step procedure. And we've given you these procedures as well as templates in the form of daily safe task instructions or even planned task observations that can be used as a form of a continuous-based risk assessment. So having some form of checklist, a step-by-step procedure on how to do the initial setup of the site, and then ensuring that you've isolated and identified each potential energy source. And that would include other hazards such as slip and trip hazards, the potential for dust, when working in ceilings, your confined space, perhaps even inadequate lighting, not being able to see inside there, you won't be able to see the potential live energy sources or other hazards that you are faced with. When it comes to isolating and locking out that energy source though, remember that all electrical work must be put in place or be done by a qualified and approved electrician. Now, we're not saying that an electrician must come out and switch off the little isolator on the DB board or turn off the actual little switch inside the DB board and then turn it back on once you're done. But obviously, any electrical work tie-in into electricity has to be approved and also has to come with a COC. This can only be done by a qualified and approved electrician. So whether you're doing it or whether you're calling somebody else out, it is vital that you get that information from the electrician as well. So a good idea or a good thing to maybe ask yourself is, have you worked close hand in hand with an electrical contractor before? Perhaps they can give you their DSTIs, their checklists, because they are the ones working with it. Encourage them to share this information with you. And if they don't want to share it, well, then let's see if we cannot get another electrical contractor, someone who's a plumber and electrician, to give us some more information on that and let us design a template for you out in the industry. Now, when you're faced with any one of these electrical energy sources, or putting in a isolation or lockout for the energy source, remember you must inform every single person, the homeowner, the client, your employees, or any other contractor working around you, of the energy source that you are going to be working with. Now, this is going to be done in the form of, let's say, a toolbox talk like this. Then you are also going to include a risk assessment. So the risk assessment must not just outline the installation or the setup of the plumbing. It must also include the environmental risks and hazards. Now, when we talk about the environmental side, we're not talking about the trees and the plants outside. We're talking about the working environment. So that is what you are exposed to at any specific site. And this is how you make things more site specific. So the risk assessment might be the same for the installation of every single type of geyser that you're installing, but the site risks will always change because you're installing a geyser perhaps close to an electrical source on the one property, and on the other property, you might be installing it at heights. So the risk assessment for the installation might be the same, but the environment is different, and that is what you must consider. So ensure that you update your risk assessments. If possible, please include signage with all of your dangers. Now, this means that when you do an isolation or you do a lockout, you don't want to have anybody potentially switch that on or automatically come and turn on the electricity while you are working, even the homeowner themselves. So you need to have some sort of signage that actually locks it out or tags that out. And your electrician should understand and know how to perform this. But what about where you're actually performing the work? Perhaps you do need electricity because there is always a need for energy to perform a site setup. You might need to have an extension cable. You might need to have portable electrical tools, which we'll look during the installation process. But if you do need that, is there a potential to put up signage, even if it's just hazardous work being done? You don't perhaps need to say exactly that there's an electrical hazard, but showing that there is hazardous work being done then just notifies people around you that are not working with a hazard that there is a potential for risks where you are working. This is almost like a potential barrier to unauthorized access to your work. This is normally done in private homes or on clients where it's not a construction site. In the construction area, if you are a plumber working in the construction site, you have to have proper barricading. And please remember that little red and white tape that you buy from the hardware store is not an adequate means of barricading. You must have proper solid barricading. This can be snow mesh, dependent on your client safety specifications, or even barricading itself like a hand and knee railing that actually has to be put around the entire area of work. Just discuss this with your client, as well as looking at your safety specification for the actual site. Now, the second part where the danger of electricity will come in is during the actual installation of your plumbing work. Now, this means you might not be directly influenced, as you see on the left-hand side in the picture there, by the live electricity, because this is obviously not live. Once we're installing electricity into a house, these are just cables. There's no electrical current flowing through these cables. But you are going to need drills, grinders, extension cords, etc., to perform the actual installation maybe of the plumbing equipment. So although the area where your hydroboil or geyser, whatever electric plumbing you're going to be installing is going to be isolated, you still need electricity in order to use your power tools. Now, in this case, power tools, first of all, must be kept in a safe use condition because the potential for electrocution must be eliminated from the source. That is where you are going to be touching the actual electric power tool, whether it be the grinder, electric cord, or the drill that you are going to be using. And all tools should have conformed to your normal SAN standard. So if it's not double insulated, if it doesn't have the correct plug points on it, if it doesn't have the correct energy, then it could potentially cause the actual electrocution, could cause a fire, it could cause a short as well. And all of that is going to affect the employee who's actually using the tool. So when it comes to power tools, please make sure that you adhere to your safety standards on this, because they must be placed on a register, first of all, And then each power tool must have a checklist which is specific to the power tool being used. Now, when it comes to the actual use of the power tool during installations, only competent employees who have been appointed in that position is allowed to use a portable electrical tool. You must inspect all portable electrical tools prior to using them, and this will be done on a specific checklist for that tool. Then you must maintain it as per your manufacturer where you purchased that tool. Always use the correct portable electrical tool for the task that you are performing. Remember, a lot of drills have got different functions on them as well. And so if you are drilling a hole, please make sure that you also use the correct function on the actual drill for the task you are performing. So it might be the right tool, but is the tool calibrated for the right function that you are using it? If it needs to be hammer action, make sure that is engaged so that you can use the tool in the correct manner. And obviously, it must all be according to standard. And that is because there's a lot of power tools on the market that are super cheap, but they are not according to SANS standard. So we do not want to buy cheap materials that could potentially put our lives at risk. Remember that portable electrical tools are also not the source of energy. They will be the source of hazard for you because you are actually holding on to that tool, but they are not the source of energy. They need to be plugged into something first. So it's very important that you need to know where you're getting your energy from and make sure that that is also free of electrocution for employees. Now, why do we say that? Well, most risk assessments that we notice is coming from the plumber themselves using their own tools. And that is 100% correct. The only difference is they are excluding where they are receiving their power from, especially when it comes to sites. And that is where we're seeing a lot of overloading of sockets because it's a new construction site. There's no power for everybody yet. And so everybody's trying to get power. And we understand we've worked on construction sites before as project managers. We know the importance of having power to each contract on site. We also understand the frustration when everybody doesn't have power when they need it. And this is where everybody is plugging into the same sockets all the time or just using the incorrect extension. Basically, it's an extension upon an extension upon an extension instead of using the correct cabling. Now, that's very important because an extension cable is only so long. If you need to extend it, you cannot plug one extension cable into another extension cable. And you can chat to your electrician about this. You need to have the right tool, and that includes the cabling that you are using. So the thickness of the cable will determine the length of current that can actually be distributed from the source of the power to the actual power tool itself. Again, this takes planning. So you need to take time. You need to set aside documentation, a step-by-step procedure for the planning of the installation, and then actually the performance of the installation. Now, when it comes to the testing of the actual plumbing work, there is also a potential for electrocution. And this is because once the installation is performed and you have now connected into the electric power points, you want to test to see whether the plumbing is actually working. The problem here is you have now energized that plumbing. So by energizing it, your risk is very high because you're not too sure whether there's exposed wiring, whether there's loose wires, or perhaps it hasn't been connected correctly. And now you are exposing yourself to live electrical power sources. So it's very important then, before you even get to the stage of testing, during the installation phase, make sure there is a procedure in place that you double check all connections. If you have a contractor performing this, perhaps an electrician that comes out, they are going to be then tying in and handing it over to you during testing. Make sure that they have all of their checks documented. The he said, she said problem that arises on a lot of sites is the cause of a lot of frustration and also the cause of a lot of incidents and accidents, where the electrician said, I did do it, but there's no documentation in place. And the plumber comes back and says, but it wasn't done when I arrived. All of that could be eliminated purely by signing off the work. And so it might take time. It might require an additional document to be developed, but all of that time and energy that you're going to put in place to get proof of what is actually being done is far outweighing the cost of the incident and accident that could actually potentially cause the life of your employee. So take the time again, proper planning, making sure you got the documentation in place. But when doing any inspections, although it might not be high risk on the risk assessment itself, we want you to treat it as high risk, since you will now be exposing yourself to an energized piece of equipment. Now, this, as well as doing inspections, are two of the highest risk areas. Now, we're not saying highest risk areas in terms of the actual potential for risk or based on the risk assessment itself. It's the highest risk because of the lack of safety during these times, during the time of doing the inspection or making sure that the actual installation is according to specification. The inspection is done generally to quote a client or check whether the work is according to your COC. Now, in the mind of the plumber, this is not a risk because no work is being performed, manual labor is being performed. But do not fool yourself or think that hazards and risks don't appear until manual labor is being done. The condition of any installation is essentially unknown. That is why you are performing an inspection. That is why you're actually going about doing the checks to see whether the installation needs to be replaced or if it can just be fixed or if it's actually working correctly. Now, since it is unknown, you should treat all of the risks as if they are all already present until you establish otherwise. So remember that. Remember that every time you inspect or test any equipment, you are working on an unknown piece of equipment. That is the whole reason why we do inspections. Now, the lack of safety during these inspections has caused a lot of incidents and accidents. And a lot of supervisors are obviously, we're not going to say to blame, but a lot of supervisors are in these positions, the ones who should be leading safety by example. And so when you go out to site as supervisors or as managers, oftentimes you feel that you're just checking something. It's just a quick check. I just need to quickly check something. That mindset must be put in place with a safety mindset. So you can quickly check something, but you can also make it safe. So when doing any inspections, when doing any testing, especially those of you who have the responsibility to check on things and not perform the actual work, treat it as if all risks are already present. 99% of the time, you might be safe. But that 1% of the time where it is not safe is the time you want to be adequately protected. So remember, electricity is a silent killer. Now, we mentioned earlier, any amount of current over 10 milliamps is capable of producing painful to severe shock. And there you can see the milliamps running from sort of safe to fatality. 1 milliamp is the threshold of sensation. In other words, when you get to 0.02 milliamps, so 0.02 milliamps is where you're going to get a mild shock. So that's when you're going to start feeling it. But notice where 1,000 milliamps is. Now, 1,000 milliamps is going to light a 100-watt light bulb. That's all it's going to light. All right. A 100-watt light bulb is going to use 1,000 milliamps of power. Way before that, in fact, 10% of that is going to potentially stop a human heart. So 10% of what powers a 100-watt light bulb could kill a person. Please remember, anything between 1 and 100, there is also additional health or safety risks, such as suffocation, muscle contraction, can't let go, and that could include other fatal aspects to a human body. So again, electricity is dangerous. Whether you are just performing the plumbing work and not the electrical, you are still exposed to electrical sources. Whether it's at the point of the actual plumbing work that you are working on, whether it's the power tools that you are working on, or whether it's the connection to the source on site to power your electrical equipment. Treat all of it as high risk, because only a little bit of electricity could potentially kill you. Which means, remember your safety thought for this week. Don't let overloaded sockets turn you off. Treat electrical work as high risk automatically. Put your safety procedures in place and make sure everyone, not just the electrician, but all employees, know and understand the dangers and risks when working with electricity. So our last Toolbox Talk coming up for this week is the risk of water. What type of water risks are we talking about? Well, tune in next week, Tuesday, and we'll take you through all of those risks that we have identified for you as plumbers. Now, if you need to get in touch with us, please remember you can email us on safety@iopsa.org or at info@ohss.co.za, as well as my personal number for any WhatsApp messages through to 071-875-2070. If you are a SIOSH member, you can get your 1 CPD point for every single Toolbox Talk that you are attending. And if you are a Plumbing Industry Registration Board member, you can get 1 CPD point for attending all 4 of the monthly Toolbox Talks. So thank you very much, and we'll see you next week.